So the question is -3 minus -7. What does that equal? All right, that is a challenging one and requires a very unique way of looking at things. So, as always, I want to begin with my first number. I have -3 to start with, so I'm going to add these 3 negative counters. So I'm going to have -3. All right, now we know that a subtraction means take away. Okay, so we're taking something away. I mean, we can work with difference, but in many cases, when we're doing subtraction, it's subtraction using take away. So here it tells us that we want to subtract -7 counters, but we've only got 3 negative counters here. So we don't have enough to subtract 7 counters, 7 negatives. So here is what you're going to do. Now, remember I said to you that a positive and a negative make 0. So if I kept adding these zero-sum pairs, which don't change my equation at all, I've still got, if I have 3 and I add a positive 1 and then take that 1 away, I'm still going to get 3. I'm still going to get the same answer. So by adding these zero-sum pairs, I'm not actually changing anything in my equation, but this is what's actually happening. So what I want to do is I want to create enough zero-sum pairs that will give me enough to subtract, okay? Enough to subtract 7 negatives from here. All right, so if you're looking at this now, you've got 1, 2, 3, 4, 5, 6, 7 negatives. Okay, so I don't need to add any more of these zero-sum pairs. I can, but they're still going to equal 0. So I've added enough. Now, if I want to now take 7 negatives away, I do that. And how many am I left with? I'm left with +4. So I love this method, but it does take quite a bit to get your head around. And this is where, when I was suggesting that you start looking at adding negatives instead of subtracting positives, this is where this more abstract level of thinking about integers really starts to help. All right. Now, in more process-based mathematics, I'm going to look at this problem again, and I'm going to look at it from an abstract perspective if we were to solve this. There are rules when it comes to integers, positive and negative numbers, and these are the rules. So the rules are a positive and a positive equal a positive. So when I've got a positive number next to a positive number, it's going to make a positive. When I have a negative, well, let's say positive next to a negative, I get negative. And when I get a negative, obviously next to a positive, I'm going to get a negative. And then when I have a negative next to a negative, I'm going to get a positive. Okay, so these are the rules. Why do they exist? A lot of the times we don't know. We just tell kids that's the rule. But when we use this method, we start to understand why the rules actually exist there. So in this case, if I was to solve this just abstractedly, I would look at the fact that this negative next to a negative is going to make a positive. So I can then say -3 plus 7. Okay, so that's what my equation actually looks like. And if I drew myself a number line and I started at -3, so let's say so if I started at -3, because we go in the positive direction when we're adding, we go 1, 2, 3, 4, 5, 6, 7. We end up at +4. So That's the abstract process. This is how you would use a number line, but this method of zero-sum pairs or annihilation actually starts to hammer home why these rules over here exist. So that's integers, you guys. If you want to know more, let me know. Otherwise, enjoy.